Okay. Oh, yes, thank you for reminding me. Anyone know this one? No? Oh, did I? Oh, I think you're right. I was thinking about it. Oh, no, I started repeating. It's good. It's worth repeating. Who is it? Anyone know who that is? Probably not. Oh my goodness. Oh my goodness.
Not risking the party and attention. Uh-huh. I wouldn't do mine.
Good afternoon. The dessert of the week right here, huh? I have your midterms. Do you want to wait? Do you want to see them now or do you want to wait? Okay.
We don't feel like we don't talk about it.
The scores are pretty good, but they were scaled just a little bit, so everyone got a little bump.
Really average.
In this class,
Yes.
I think it was like a 61
Out of
100. I'm just kidding. I don't talk about averages, but it was pretty good. It went from lowest to highest. It was 195. So you can't, you can hold this, but I'm gonna collect it. We don't release it.
okay. Literally when my graphing calculator thing is the debacle, I'll have it better.
Thank you. Baron. That's it. I wouldn't do that. I also have your grade reports.
What is the?
The nice thing about the grade report is you're gonna see what actual percent you got on this, because whatever percent you just calculated is gonna come up a little bit. Because again, it was scaled up. Yes, really? Corrections, if you want to come to the office and do them together, you can, but I'm not required to do corrections.
Okay, what is it like?
Ready? Yes.
Thank you. We're getting the grade up. Wait, Mr. Bigwood, are these reports including our dropped lowest test grade? Yeah, right.
I have to replace them.
By B plus.
Nice. So I gotta make some adjustments.
Oh, let's adjust.
Wow. That's some great news.
Yeah, can I just come by and meet with you sometime next week? Come on, Charlie. Like,
Oh.
yeah, I think.
You got the grade?
Wait, so
So there are two mid-year assessment grades. One is not for points. The other one is one's scaled. Like the one that's not for points, you can see your points, but it's not part of the calculations. Yes.
even if.
Maybe I made an error. Yeah, this seems wrong.
It should be a 50, then it's not.
Yeah. Well, I don't know about, I don't think we have that.
You can't get lower than 50. Here. Everything gets worse about it. I know I'm missing a few, Pearson, can I get those in and get credit?
If you send me an email when you're complete, then follow up. Which quiz was that?
Quiz 1, unit 3, 1.6 and 1.6.
Oh, no, that is correct. The way that works is every quiz is worth 25 points. That is you need to find that quiz. Mark that, correct?
Oh, was that the online one?
Oh, that may have been the only.
I know I did that. I mean, word space though, that has to be at 50.
Yeah, maybe that. So, I give you a few more minutes with your tests, just to look over them. And if you want to look over them another time, you're welcome to come by the office, but I can't let you take them.
So is this score written here with boost or without?
That's without. So look at your and see what, there should be a 100% and like bring it down.
No, and I love it.
We see how everything is categorized on the outside.
Where is it? Wait. My function's missing. Hey, Mr. Leader. What's wrong with this?
One more, please.
Okay, Chloe, what you think about it? That's an open circle. That's an open circle.
No,
I
Ray,
don't-
y'all know Ray. That's stupid.
To make those terms. Oh, yeah. I'm fine. What is, why is this minus one? Why is there a sign? It's below the line. I've just circled it.
Yeah.
That is really sad.
Yeah.
Oh.
That's fine. What's wrong with it?
Oh, I didn't, you didn't.
Okay, so I can come around and pick up the areas. There's mid-year.
Why not? But I know, I want to understand what I have. Right. Worst case, I know. Oh, I can. Are we going to get our things?
Yeah, I'll give you an updated.
What?
Grade sheet?
Yeah.
I'll give you an updated grade sheet. Okay, so, there are two errors on the grade sheet. So one of the quizzes was counted as a homework, but, quiz 3 was, with, I think 1.6, what is it? Yeah, which one is it?
Yeah, 1/6.
1.6 and 1.7. Okay, yeah, from Halloween, I think, it's like 10:30 or something like that. So I need to recategorize that because quizzes are worth a little bit more than homework. And also, I completely forgot to replace your lowest test grade with your mid-year exam grade. So if you did pretty well on this one, and you have a test that's been bringing you down, that will be replaced. So I'll give you an updated grade report next time I see you. It's the lowest test grade. Replacing your lowest test grade. So one thing that's nice about this is you see on the right side, there's a little like effect to your grade, like it says +3 or -2 or something like that. So if there's a test, it's like -4. If you did better on the mid-year exam, that score will replace that one. And maybe it'll be a -2, maybe it'll become a +1, I don't know. But that could do some significant turning things around. Which is really nice. So sorry for having to do that, but I will. And thank you for reminding me. And again, if it is important that you know what you did wrong. So at some point, I do urge you to come by the office and at least sit with it. If you want to sit with me and talk about it, let's do that. But regardless, each one of you is coming super fun, and you feel that you're learning. You feel it. I can see it, and the results were on you. Even if you didn't do it, it was light. You're definitely learning, and I appreciate your effort. Okay. Let's do some math, shall we?
Sure.
Let's get right to it. We didn't quite finish the section last time. So I'm going to today. Maybe later. And if you really need to, you can. But I forgot. There's a little issue here. We made a mistake last time, if I remember correctly. Where is this? Oh, yeah. This one.
Like ball player one.
I don't think it actually reaches 36.81 feet. The 59 is correct, but that 36.81. I think so. Could you please recalculate that? And in the meantime, I'm gonna get my calculator. Am I wrong? Is it okay? You have the same thing? Maybe I did it wrong. Let me check here. Oh, my bad. 36.81 is correct. Maybe I was thinking something else. Okay. Anyway, let's do this last problem on this section. A food truck. What's that word? Do you know what this word is? Gyro. Exactly. What is a gyro? A Greek sandwich. It's like a wrap. Normally with lamb, I think. Okay, so a food truck gyro vend, maybe that's the name of the truck. Has weekly fixed costs of $525 and variable costs of $5.75 for each gyro combo prepared. Let X represent the number of gyro combos prepared and sold each week. Write the weekly cost function C for the food truck vendor. Hence, the cost function is the sum of fixed and variable costs. So this is what whoever owns this food truck has to pay. What it costs to run this business. We're going to say C of X is equal to 525 plus 5.75 X. All right, so even if they make 0 sandwiches, they still have to pay $525. Hopefully they're making sandwiches, because they're making money. Yeah.
I feel like people do.
The function R of X is equal to that. Describes the money in dollars that the food truck vendor takes in each week from the sale of X gyro combos. What do you think that R stands for? Revenue, exact revenue, money coming in. Use this revenue function and the cost function from part A to write the vendor's weekly profit. Profit P, excuse me. Hint, the profit is the difference between the revenue and the cost function. So we start with.
What's the revenue?
Good question. Maybe if you make too much, it becomes wasteful. Start losing money. Minus cost of X. Yeah, some of these, it takes a leap of faith more than anything else. It's a little bit forced. Okay, we know that R of X. I don't know what P of X is, but I know that R of X is that monstrosity, 0.001 x squared plus 8.95 x minus the cost, which is 525 plus 5.25 x. What's that? Oh, 575. Thank you. Good catch. Thank you for paying attention. What do you think that 8.95 represents? Sale price. That doesn't. They're selling it for $8.95 each. But there's not like they're making $9 off because it costs them existing basis. But we can combine all of this to P of X is equal to negative 0.001 x squared. Do I need a calculator to put these terms together? No, 895 minus 575 is exactly 323.2 x minus 525. That is a profit that they made, according to this problem. Use a vendor's profit function to determine the number of euro combos that should be prepared and sold each week to maximize profit. What is the maximum weekly profit? I'm going to give you a moment to work on this part, but discuss it with the neighbor how you're going to do it and then actually get that answer.
So vertex. And like 16,000. You know, you talking about that, oh, yeah. You know, and then you get that something.
I will be calling on someone to help me with this. Oh yeah. Oh, it's not bad. You're skeptical. That seems like a whole lot. That's like prime. Prime. Yeah. Yeah. I think they could get it under $3.
How would that fall out?
Yeah. Yeah. Me neither. Make sure to take econ as a senior. Maybe they'll explain when you take economics class. AP economics. Are we ready? Let's see. For C, Ivy, could you help us out with this, please? Hey, please. Okay, over negative 0.001. Oh, thank you. Oh, and it's still frozen, sure it is. I missed it. And you multiplied it by 2 automatically, didn't you? You just made that a 2. Is that what I heard? Is that what you did? I like it. Okay. 1,600. Are we good with that? 1,600? Okay. Does that sound right? 2035? I'm trusting here. 2035. Exactly 2035? Interesting. Any questions? When it says 1,600, what does this represent? That's the number of Euro combos that they had to sell to make a maximum amount of profit of $2,035. Is that per week? Nice. I like that. Okay. So of course it's a word problem. You'll answer as a sentence. They need to sell 1,600. Let's see. So the number of, yeah, they need to sell 1,600 combos to make a maximum of $2,035. Okay. Moving on. Finish 3.1, and let me take this time to remind you what's coming next time. Remember what's happening next time? We have a little quiz. Yeah. Yeah, so it's gonna be on everything from the quadratic so far, plus whatever we do today. Something to look forward to. It does for second semester. Yeah. Okay, polynomial function. We've already studied polynomials. Function it just means we have inputs and outputs. I hope it makes sense that polynomial function is just f of x equals all of that stuff. Are we good? We have studied polynomials before, haven't we? Okay, I know it was last year, but I hope you remember. All that needs to be true is that these exponents can't be negative, and they could be zero. They can't be negative, and they can't be a fraction. They can't be a fraction, right? They gotta be, what kind of number are we talking about? They can't be negative and can't be a fraction. Whole number is nice. Is integers okay to say? Why not? Because negative numbers could be included then. So yeah, whole numbers. What are numbers called if you don't include zero? Like all the whole numbers without zero? Natural or counting numbers. Okay, so here we just determine if it's a polynomial function. If so, identify the degree. So the first one, do you already know? Is it a polynomial function? Yep. What degree is it? Second. Second degree is called quadratic. On fire. Thank you. Discuss with your neighbor the rest of these.
He is second.
No, yeah.
Yes. Okay. You ready? Ready or not? Let's see what you got. B, thumbs, yes or no? Is it polynomial? No, the problem is that -1. No, not a polynomial. Boo, that -1. Oh, what if we write it as 1 over x? Now is it a polynomial? It's a fraction now. It's got, yeah, right. So even though it's kind of written in this form, it's got to be a constant times some number of x's, right? X to the n, x to the third, x to the second, not x to the negative first power. C, what do you think? C or no? I'm sorry. C is not a polynomial. It is a quotient of polynomials. We have to be able to write it as a term, plus or minus a term, plus or minus a term. So it is not. D, what do you think? Yes, it is. What degree is it? Is it? It's a 0 degree. I'm gonna write that in letters, 0 degree. Good question. What would first degree look like? Is it possible? 3x, like plus 2. First degree. Do you see the one? Do you all see the one? It's the exponent on the x. Yeah, that's what we're saying here, right? So like what we see here for this polynomial function is a degree n. You look at the highest degree. So since d doesn't have one, we can imagine this as being x to the 0 power, to the 0 degree. So moving on to E. What do you think? Is it a polynomial function? Yes or no? Yes, it is, because we could do what? Multiply it out, right? If you multiply that out, wouldn't it just be exactly what we're looking for? It's not a term plus a term plus a term plus a term. It's a polynomial, even though it's in a special form called factored form. Ooh, yeah, it's factored form, but it's a polynomial. But what degree is this? Would you please hold up what degree you think this might be? Fifth is a good guess, but it's not 5. Imagine you were to actually multiply it all out. Imagine what that highest one would be. Check with your neighbors. I'm seeing all sorts of different numbers. So what is it? What degree? Yeah, it's 8th degree. Are we good with that? Does that take a lot of work to do? Should we actually multiply that out to check? No. Yeah, just look at the leading coefficient from each, or the leading term of each one, and you're good. Oh, there's more. What do you think, polynomial? Polynomial. Doesn't break any of the rules. What degree? Not 0. Not 0. I know it's weird. It's weird. It's not first either. And let me tell you what the degrees are connected to. The degrees are connected to how many times the graph might cross the x-axis. Like x squared, you know what x squared looks like? It's a parabola. It would cross an x-axis possibly how many times? 2 times, right? A parabola. Not all of them cross 2 times, but just how many times could it cross? It crosses it exactly 2 times, so degree of 2. First degree, it crosses 1, right? A line would cross it 1 time. X equals 3, it doesn't cross it, right? It's up here, so 0 degree. X equals 0 crosses it everywhere. So we just don't have a degree for it. We're not going to say it's an infinite degree, it just doesn't have a degree. Now that's really, it's a weird thing. If you don't get it, don't worry about it. That's weird. I'm gonna say no degree. Like nothing. No degree is the official verdict. Yeah. It's awkward. Graphs of polynomial function. We've only graphed 2 types of polynomial, well, 3 types of polynomial functions so far. Quadratic. linear, and how did we get cubic? But we were on quadratic, linear, and constant. Right, we graphed all three of those. We're going to be graphing cubics. What's above cubic? Quartic. I know it seems like it should be quadratic. Quartic, do you remember the fifth degree? Quintic, right there, or quintic. I think there's a either way. And that's as far as I know in terms of labeling it. After that, it's just a 6th degree polynomial, 7th degree, etc. So we're going to be doing them. And the thing that binds them all is that there are no corners, there are no breaks. Like you're never going to see anything that looks like this. Above the 1st degree, it's always smooth and curved like this. Like, you know, these are both really good examples of polynomials. So I never want to see something like this when you're graphing your polynomial. And some people are going to do that because you're going to like trying to get the zeros in and forget that it's got to be nice and smooth, no sudden movements like at that one. Right, the beautiful, beautiful polynomial here, smooth rounded corner, smooth rounded corner. That's how it's always going to be. So yeah, something to look forward to. Okay. Bless you. We're not gonna use a calculator for this. Let's graph some functions. Y equals X. I think you know what this looks like. You better know what this looks like. Show me Y equals X. With your arm. Do people still dab? You do that? Do that? You do it? No. It was huge, like in 2018, right? When you were like in what, 4th grade, 3rd grade, everyone was like, just hitting it. Okay, so it's kind of like that. Y equals X squared, you know what that looks like? Everyone does that quadratic dance, right? Quadratic. I'm just kidding. No one does that. Outside of this class anyway. So why does this go up on both sides again? Exactly. Or when you square a negative, it becomes positive. And I think, have we talked about this already? These graphs? I feel like we did it when we were doing our parent function. So y cube, we know it goes up here and then it goes down on the other one because when you cube a negative number, it stays negative. So if I want to do like y equals x to the 10th, we know that's, will you show me what that looks like? Will you show me the x to the 10th dance very briefly? X to the 10th, right? It's this one. The pocket dance would be this one. It goes up like this. So it's important to see these generalizations as we talk about polynomial functions. Okay, so the summary, power function is just x to some whole number power. Now, if that n is a positive integer, if n is a positive even integer, if n is a positive odd integer, it's going to look like two different things. So if it's even, it's going to look like this up on both sides. If it's odd, it's going to look like this. Sometimes we describe it like this, as x goes to infinity. Have you seen something like this? If x goes to infinity, y goes to infinity. Does that feel comfortable? Right, as x is being bigger and bigger, y. Good question. Does zero count as positive? It doesn't have a negative on it, but it's kind of positive. What kind of number is zero? Neutral. It doesn't take sides. Would one work for the other side? Would one work for the other side? Well, it's odd, so I think it's going to look at something like number 2. But let me finish up this idea. Of course, as x goes to negative infinity, y is going to go to infinity, so going up. Y is going to infinity. in this case, as x is going to infinity, y is going to infinity, and here as x is going to infinity, negative infinity, excuse me, y is going to, is it negative infinity? I hope you all see that. There's nothing to be memorized, it's just understand what we're writing about. Something that's going down like this, so x is going to negative infinity. Like marching that way, every y is going down. How down? All the way to negative infinity. Yeah, it has the same behavior. It's not curved, but it's gonna go up. Up over here and down over here. So it has the same, we call that end behavior. That's gonna be huge. So here it is, example 2, use the leading coefficients test to determine the end behavior of the graph of the given function. Okay, so end behavior. Same as first term. What I mean is that if we're to look at x cubed, this first one, x cubed plus 3x squared, etc., the end behavior is the same as just f of x equals x cubed. What does x cubed look like? You show me the dance. Right, like this, right? Going up over here, down over here. As x approaches in positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. So we could draw that as a picture. That's the end behavior. Or we could say as x goes to positive infinity, x goes to negative infinity, etc. Let's just check this. Do you have your calculators today? Do you have your graphing calculator? Who has yet to get the graphing calculator? I just not charged. Do you want to charge? We actually, yeah, you can charge it here. So just make sure you're sharing with them. And James, you're gonna be able to get one soon. Okay, awesome. And who else doesn't have one? Okay, so you, yeah, take it on the face should be facing you. The key should be facing you, just like that. Yeah, and you're all welcome to charge here whenever you want. I recommend if you're gonna charge here, leave your phone here too, because it's highly unlikely you will leave your phone, but it's 50-50 that you're gonna leave your calculator if we don't use it in class. So if you're charging it, you may want to put your phone up there too at the beginning of class. But yeah, let's type this in. F of x equals x cubed, etc. Or forgot my attachment position. Yeah. The whole thing. Okay. Let's see if I can make this work this time.